Hello, today we're going to look at even and odd functions and their graphs. All right, so graphically when we're looking at a function is even if the graph reflects across the y-axis. That means you can fold it hocked out style and it would match up. So if you recall, this is my y-axis. So if it can fold evenly across this y-axis, then it is even. So I change. This is my x-axis, and here is my y. A function is odd if the graph has a 180-degree rotational symmetry about the origin. So here's my origin. If you recall, the origin is that place where the x and the y axis intersect. And if it looks the exact same on both diagonals, then it's an odd function. And we'll see some examples of that. I have to also mention the actual rules for even and odd functions. Because sometimes, I know for myself, I am not as, I can't see things too visually. So sometimes I have to use that formula and that rule. So let's go ahead and look at the rule. So if it's an odd function, we know that if I have if I plug in a negative, the negative of my x, I should get the opposite of my f of x. So for example, here I have 4, 4 as one of my points. So say 4, 4 is one of my points. If I plug the negative value of my x, which is a negative 4, which is down here, I should get the negative value of my f of x, or my y value, which is negative 4. And so you see that happens here. So also one way that I like to look at it, here's my origin. If I look in this quadrant and this quadrant, the diagonal quadrants from each other, I know that if I fold it like that, then they will match up. Same for this quadrant and this quadrant. If I fold them going in this direction, in that diagonal direction, they're the exact same. For even function, if I plug in the negative of my x value, I should get whatever I got for the positive. So that means, for example, if I have a 2, I get 4. Well, if I plug in a negative 2, I should get 4 as well. And that's what happens. If I plug in a negative 2, I get 4 as well. Now, if the function is not even or odd, we say that it's neither. So it doesn't follow either of these rules. All right. So here, another example of an even function. Again, if I plug in a negative x value, I should get the positive y. I should get the exact same y value, whether it's negative or positive. As you can see here, the y values are the same. And odd, they're going to be in the opposite direction. So if I have a negative x value that I plug in, when I plug in the positive, it's going to be the negative of that. So here, if I plug in an x, I get f of x. If I plug in the negative of that, I get the negative of that f of x. And that's what odd is. And also, again, if I look at my origin here, looking at the diagonals, this looks just like this, and this side looks just like that if I fold it diagonally. All right, neither, it doesn't follow either rule. If I look at my y-axis, if I fold it across, there's not the same. And if I look at it diagonally, it's not the same. All right, so here's an example. If we have this function here, let's take 5 for example. So let's say my x equals 5. I can probably easily see that it's not even, but it definitely looks odd. So let's go ahead and say that it's odd. And we know that the rule for odd is that if I plug in the negative of my x, I should get the negative or the opposite value of my y. So here I have positive x. When I plug that in, I get negative 5. So my f of x is negative 5. All right, so now let's do for up here. So if I do the negative, so here I did 5, I want to do the negative x. So the negative of my x would be negative 5. And that means that I want the opposite value, right? So it's the opposite because it's the negative. So I want a positive 5. So when I put in a negative 5, I get positive 5. So that does justify it is negative. And so if I was to actually use the formula of if I plug in a negative x, it gives me the negative of my f of x. And so negative 5 turns to positive 5. All right, here's another example. Again, I can look at this and see that it's definitely not even, but it looks, the diagonals here look the same, and the diagonals here look the same. It looks like it's probably odd. So again, I'm going to choose, let's see, what is a good number to choose? Let's choose 1. So when x equals 1, it looks like f of x is also equal to 1. So when x is 1, y is 1. Now, let's do the negative. So I need negative 1. So negative 1 is here. And then I'm looking for it to be the opposite of 1. And it definitely is. So it is negative 1. So that means that it checks out. It is odd. All right, here I can easily see, I don't need to do, I can see that this is my y-axis. It's not reflective, so it's not even, and it can't look at my diagonals either, so it's not odd. So this one definitely has to be neither. I don't even have to check it. Okay, let's look at the next one. This is my y-axis. It looks like it's pretty even to me. I'm going to say it's even. If I have some doubt, I need to check it out to see. So let's check it out and make sure that we are on the right path. So let's take x equal to 1. So when x equals 1, it looks like f of x is equal to negative 2. Now I want to plug in the negative of that and see what I get. So x equals negative 1. Hopefully I get negative 2 again, right? And it is. So at negative 1, f of x is equal to negative 2. So they're the same. So that means that it's even. All right. Here I have an example. It says g of negative x equals g of x. So we know that it's even. We can also look at it and see that if I cut it right down the middle, it looks the exact same on both sides. Here's another one. I don't even really need to test. I can see this easily. That is the exact same on both sides. If I cut it straight down the middle, fold it hot dog style. So this one is also even. All right, here's another one. It does not look even because I don't have the same points here, but it looks like it could be odd, and they even give us 2 points because they're so nice. So if I plug in x equals 2, then my f of x is my y value is equal to 2 also. And if I plug in x equals -2, the negative of that, I want the negative of this f of x. And it is negative, we can see here. So it is the opposite. So it is odd. Here, I'm not going to do the formula because I can clearly see this is exactly the same on both sides. So this is even if I fold it hot dog style. And I hope that this helps.